Alright guys, welcome to this page of the notes. Now what we're going to do is we're going to start to practice graphing transformations. And I'm going to kind of ease you into it. So what I've done is I've already given you the graph. I just want you to now be able to recognize the transformations. Have I given you an H, a horizontal shift? Have I given you a K, a vertical shift? Have I given you an A, some sort of dilation, either a shrink or a stretch, right? So let's go ahead and take a look at this. What I've given you is y is equal to the absolute value of 2x. Now let's remember what my general function looks like. So from the previous page, we remember that for absolute value, y is equal to plus or minus a, absolute value sine of x plus or minus h, close the absolute value, plus or minus k. All right, now let's take a look and see what I've got. You've been given the function y equals the absolute value of x plus 2. Now let's go ahead and see if we can identify what kinds of transformations I've been given. A, h, and k. All right, here we go. The first one. If I have a dilation, I will have some number multiplied in front of my absolute value. Is there anything there? No, there's just a 1, right? There's an implied 1 in front of that absolute value, and 1 does nothing to the graph. 1 is neither a stretch nor a shrink. It does nothing, so I have no dilation in this problem. The next is an h. Now if I have an h, there'll be something, a number, inside of the absolute value sign with my x. And I don't have one. So that means there is no h. H is 0. And I don't have a horizontal shift. Okay, well, if I have a vertical shift, k, it's going to be some number tacked on after the absolute value. And I do. I have a plus 2 back there. So that means that my k is a positive 2. And now all I need to do is remember what happens when k is positive. Well, the nice thing about vertical shift is it does exactly what you'd expect it to. When k is positive, you are going to have a shift up. Now here's what I've done for you. I have already graphed these. In blue, I've given you the parent function y equals the absolute value of x. In green, I have given you the graphed transformation, absolute value of x plus 2. What we would expect is that the parent function in blue has now been shifted up 2 units. And that's exactly what has happened with my green graph. I've taken each of these points and shifted it up 2 units, right? 0, 0 now goes to 0, 2. 1, 1 now goes to 1, 3. 1, 2 now goes to 1, 4, right? I'm adding 2 to the y value of each of those guys. That's exactly what k does. It takes that parent function and shifts the whole thing up 2 units. Let's try another one. All right, here's what I've got. In this one, I recognize it immediately as the quadratic because my x is squared. So let's write out our general equation from the previous page. We know that y is going to be equal to plus or minus a times the quantity x plus or minus h squared plus or minus k. All right, well, let's take the graph that I've been given. Y is equal, the function I've been given, negative x squared. Okay, let's take a look at our transformations, a, h, and k, and see if I can figure out what I have in this function. All right, well, the first one we're going to look for is an h, right? If I have an h, it'll be inside the parentheses with the x, that whole quantity squared. I don't even have parentheses, which means there can't be an h, so that's 0. There is no horizontal shift in this case. If I have a k, k will be tacked on the end after the x squared. Well, there's absolutely nobody back there, so I can't have a k. It must also be 0, which means that I have no vertical shift. All right. If I have an a, it's going to be in front of the x squared, and looky there, I do. Now this one is a little tricky though, right? The value of a is that implied 1 that's always written, and remember we said that whenever a is 1, this does nothing as far as a dilation goes. It neither stretches nor compresses, right? Because 1 times anything is itself. It doesn't change the graph at all. So if I don't have a dilation, what is actually going on here? Well, we notice that it's a negative 1 in front, which means I actually have a negative 1 for a. And now I remember from the previous page, whenever there is a minus sign in front of that function, that is actually going to flip my graph across the x-axis. So what I've done is I have graphed the parent function y equals x squared for you in blue. We know that that is a parabola, that U-shaped graph going through the origin. But I now have y equals negative x squared, and I know that the negative sign out front flips that graph across the x-axis. I'm going to take that U shape that's opening up, I'm going to flip it across the x-axis, and I now have that U shape opening down, but it is still going through the origin, right? All I've done is a reflection. This is a reflection transformation across the x-axis. Awesome, let's try another one. All right, here's what I've got for you. I've given you this function y equals 4x. Well, it's not an absolute value, so it's not an absolute value function. The x is not squared, so it can't be quadratic. And if it were the constant function, it would just be y equals a number. So this has got to be the linear function, the identity function, because that x is to the first power. So let's write that one. The general equation is y equals plus or minus a times the quantity x plus or minus h plus or minus k. All right, well, here we go. I have y equals 4x. Let's see if we can figure out a, h, and k. All right, once again, if I had an h, it would be inside parentheses with the x. And I have no parentheses, so there can't be an h, it must be 0. If I had a k value, I'd have something tacked on to the end. And I have nothing tacked on the end back here, so there is no k value, it must also be 0. I have neither a horizontal shift, nor do I have a vertical shift. Neither of them are happening here. So what do I have? Well, I've got a 4 multiplied out front. That must be my a value. And now I remember back to the previous page that if a is greater than 1, this is going to be a vertical stretch. And if a is a fraction, meaning it's less than 1 but greater than 0, this is going to be a compression or a vertical shrink. We'll call it compression. Right? That's what I remember from the previous page. Well, since 4 is greater than 1, I have a vertical stretch. I'm going to grab onto that graph and I'm going to stretch it vertically. What it should do to my line, right, if this is my identity function, as I stretch that graph vertically, it should take that line and pull it more steep, right? As opposed to if I had a number like a fraction, like 1/2 or 1/4, that would be a vertical compression, which means I'd take that identity function and I would kind of begin to flatten it out as I compress that graph down. Well, we've got the one where a is greater than 1. So we're going to take that identity function, we're going to kind of stretch it out. We're going to make that line much steeper. That's exactly what I see here. Remember, the parent function is y equals x. That's the graph in blue going through the origin, right? That graph in blue. Well, if I were to grab onto that graph and stretch it, right, you would see that that steepness would increase, which is exactly what I see here in green. Y equals 4x. I have simply taken that graph in blue, that parent function, I've stretched it vertically, and I have a line that is much steeper now. Hopefully this helps give you some insight into the kinds of things I'll ask you to do when it comes to transformations. Head on over to the next page and we'll get a lot more practice. I'll meet you there.